All right. So it says apply the vector, and then you have this vector notation of 6, -9 to each set of coordinates. Drag and drop each set of coordinates for the resulting image next to the set of coordinates for the pre-image. So these are the resulting images, and then these are the pre-images over here. And so if I take a pre-image ordered pair like 2, 2, and I apply the vector 6, -9, it means this is +6, so I'm going to add 6 to 2, and this is -9, so I'm going to subtract 9 from 2. So it's going to turn into 8, -7. So which one of these starts with 8, -7? Looks like this one. And I'm not sure if that's enough just to go through the first one, but we try it. So 7, 9 is the first ordered pair of this pre-image. 6 and 7 added together is 13. And then 9 plus -9, or 9 minus 9 is 0. So it looks like this one goes here. Does that make sense? Enter the coordinates of the image under the transformation. Okay, so the first ordered pair XY is the very general rule, and basically what it's doing is it's taking vector notation of, see where it's like pointy brackets, and we're changing it into where we have the smooth parentheses. Okay, and so we're writing the coordinate rule. We're taking the vector notation and going to a coordinate rule. So coordinate rules are what you'll probably be more likely to be tested on versus the vector notation. But the way I transform it, because this is +7, I'm adding 7. And because this is -12, I'm subtracting 12. So as you go through the specific ordered pairs now, you're going to do this rule, and you're just going to keep repeating. So the x coordinate, whatever it is, you add 7 to it. 1 plus 7 is 8. And then -2 is your y coordinate. So you're going to subtract 12 from it. -2 minus 12, that's like adding two negative integers. It's -14. So we're in HMH on number 6. This is 2.1 translations. It says select the name of the vector and complete its component form. So component form is vector notation. They mean the same thing. The name of the vector is vector. So our choices are GH or HD. The way you decide which one it's going to be is look for the arrow. Okay, wherever the arrow ends up, that would be the second letter. So it's going to be GH. Starts at G, ends at H. Initial point, terminal point. And the component form, so I need to put two numbers here. You know, how do I get from point G to point H? So I have to, in the first box is the x coordinate, tells me how far right or left I move. So to get to H, I'm going to have to go to the right, which is a positive number. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be an 8 on mine. And then to get to H now, vertically, I either have to go up or down. If I move up, it's a positive number. If I move down, it's a negative number. So I'm moving down 1, 2 units, so -2. How you do that one. All right, so on this one, it says specify the component form of the vector. All right, so down here, this is the component form of the vector notation with these little like pointy parentheses that maps the figure to its image. So it's not specifically telling you which one's the pre-image and the image, but when you are given ABC and A prime, B prime, C prime, ABC is the pre-image, and then A prime, B prime, C prime is the image. So we want to know, how do we get from the blue triangle to the green triangle? And so because the triangle does not change size, it stays congruent in its shape. It's the same movement for all three vertices. So whatever I do to point A to get from here to A prime, I have to do the same exact thing for B to get to B prime, and it's the same movement for C to get to C prime. So just pick any two letters that go together, like C and C prime, right? And then figure out, how do I get from this point to that point? So am I going to go left or right? I got to go right. How many units do I go right? Looks like I go 4 to the right. So that is your x-coordinate, positive 4 in this case. And then once I've moved 4 to the right, I either have to go up or down. Well, it looks like I need to move up, and I would have to move up 5 units. So 5 should go here.